Hello class, today what we're going to talk about is finding arc measures. Now when I talk about arcs, we're not talking about big rudderless boats or welding or anything like that. What we're talking about are parts of a circle. So here's a circle, and an arc is just a piece of it. So something like that. That is an arc of a circle, and we're going to be finding the measures of the arcs. All right. Now, arcs are measured in degrees, just like angles are. And the measure of an arc is the measure of the central angle. All right. So here we have arc AB. And arc AB is formed by angle ACB. All right. C is the center of the circle. So since angle ACB has C as its vertex, this is referred to as a central angle. And the measure of the arc is the same as the measure of the central angle. So since ACB is 50 degrees, the measure of arc AB is 50 degrees. All right. Now, this is a minor arc. And a minor arc is defined as an arc that is less than a semicircle. A semicircle is, of course, half a circle, so it has a measure of half of a circle's measure. Since circles are 360 degrees, a semicircle would be 180 degrees. All right. Then you also have major arcs. And a major arc, that is going from A to B the long way. And so we have to call this arc ADB. Have to use this other point in the middle to show, hey, we can't just go from A to B. We have to take it through point D. All right. To show that we've got to go the long way around. And the way you find the minor arc is, the major arc is 360, the length of the degrees of the entire circle, minus the central angle. All right. So it'd be 360 minus 50, so the measure of the major arc ADB is 310 degrees. All right. So for a minor arc, it's just whatever the central angle is. For the major arc, you take that minor arc and you subtract it from 360. All right. Okay, so let's take a look at a couple of these. We need to find the measure of each arc from circle P. And it tells us that segment RT is a diameter of the circle. So first, arc RS. So it's just using R and S, so it wants to go from R to S the shortest way possible. So it's just going to be this one here, the minor arc. And the minor arc has a measure the same as its central angle, so 110 degrees. All right, so that's all it is. I don't know why it's got, the measure, it's the same as the measure of angle, RPS. Okay, so next we have RTS. So R through point T to S, so this is the major arc. And to find the major arc, we take 360 degrees and we subtract it by 110. Take the 110 out of it, and that leaves our major arc. So 360 minus 110 equals 250. So the measure of arc RTS is 250 degrees. Now it wants us to find RST. So RS to T. Well, on this one, that would be this whole thing, or this whole thing, which it doesn't give us any measures there, but it does tell us that segment RT is a diameter. And since that's a diameter, that means it cuts the circle in half, and so this is a semicircle, so it's a measure of 180 degrees. All right. All right. So what I want you, this first. Arc addition postulate. This is just like the angle addition postulate or the segment addition postulate. And what this says is that the measure of two adjacent arcs is the sum of the two arcs. Measure of two arcs. So the measure of arc ABC is the same as the measure of arc AB plus the measure of arc BC. All right, pretty common sense stuff there. So let's take a look at this. We need the measure of each arc. So arc GE, so G to E. Well, GE is going to GH and then HE, so we can just take 40 plus 80. So the measure of arc GE is 120 degrees. Next we have GEF, so GEF. Well, we know that GE is 120 degrees, and we know that EF is 110, so we can just take those two and add them up. 120 plus 110, which gives us a measure of 230 degrees. And the last one we have is GF, so GF, this minor arc here, except we know that this is 230, which means this is the rest of it. So we can just do 360 minus this 230 to give us 130. So not too bad, pretty easy stuff. Okay, so here we got a situation that gave us recent survey asked teenagers whether they would rather meet a famous musician, athlete, actor, inventor, or someone else. Graph shows our results. So we need to find the indicated arc measures. So the measure of arc AC, so A is here, C is there. So here we have AB, which is 29 degrees, BC is 108 degrees, and so we just add those up and we get 137 degrees. Next, ACD. Well, we know AC already. Arc AC is 137, and to that we just need to add this 83 degrees for the athlete section, right? And so that's what we do. 137 degrees plus 83 degrees gives us 220 degrees for the measure of arc ACD. All right, next we have ADC. Well, this is different. ACD and ADC are two different things. ACD is going through C to D, so it's right here. ADC is going through D to C. So that's a different arc. It's going to be a little bit different there. So what we can do with this, though, is we know the measure of AC, so we can just subtract that from 360, right? Because we're looking for the other half of the circle, the other piece of the circle. So 360 minus this 137 right there. So 223 degrees for ADC. Okay, so next we want EBD. So E to B all the way around to D. Well, we could add these four up, or we could just take out ED right there, right? So that's the easiest way to do it. That's the way we should do it. 360 degrees minus the measure of ED, so minus 61 degrees, which gives us a measure of 299 degrees. All right, so not too bad. Now what I would like you to do is answer these 6. So pause the video, work out these 6 problems right here, and then come back and check your answers. All right, let's see how you did. Number 1, this is a minor arc because it is less than a semicircle, less than 180, and the measure is 120, same as its central angle. Number 2, QRT, so going all the way around there. That is a major arc because it is more than a semicircle, and it has a measure of 240. And all you have to do is take 360 degrees minus the 120 for QT. All right, number 3, this is TQR. Well, you add those up, and that's 180 degrees, right? Which is a semicircle. It's half a circle. So this is a semicircle right there, which means that TR is a diameter. Okay, arc QS. So here's Q, there's S. What to do there? This is 160 degrees. A couple of ways you could do this. Easiest way, Q to S, that's 360, and you could just subtract 120 and 80 from 360. That works, so that's 200. Or, since this is a diameter, that means that TSR is 180, and you can subtract 180 from 180, so you find out that this is 100 degrees, and 60 plus 100. A couple ways to do that. Alright, arc TS, well, that's just right there, that's 80 degrees, because that's our central angle. Minor arc, because it's less than 180. And RST, arc RST, well, that's the other half of TQR, isn't it? We already said that TR is a diameter, so this is a semicircle, 180 degrees. So that's that. Not too bad. All right, we got another theorem here. This is the similar circles theorem. All circles are similar. This circle is similar to this circle, which is similar to this circle, which is similar to that circle, right? If you remember from back in elementary school, you called similar was the same shape, different size. All circles are the same shape, and so they are all similar. All right. Now, congruent circles. Two circles are congruent if and only if they have the same radius. Okay, so if they're basically if the radius is congruent. So since AC is congruent to DB, then the circles are congruent. Right? Because then they are the same shape and the same size. So congruent central angles. In the same circle or in congruent circles, two minor arcs are congruent if and only if the central angles are congruent. So since angle CAB is congruent to angle DAE, that means arc CB is congruent to arc DE. Alright, so let's take, that was weird, it skipped a page. Okay, so here we go. Tell whether the red arcs are congruent, explain why or not. So we have arc DC and we have arc EF. Both of these have central angles that are 80 degrees. Are they congruent? Oh yeah, they're in the same circle, and so the arcs are congruent because they're in the same circle and they have congruent angles. Okay, arc TU and arc RS, they have the same angle, but they do not have the same radius. So since the radius is not the same, the arcs are not congruent. So these are not congruent because the arcs do not have the same, the circles aren't congruent. Okay, so number C, we have arc UV, arc YZ. They have the same central angle and the radius is congruent, and so these are congruent arcs. Alright. Last thing here, I want you to answer these two questions. Are the arcs congruent or not? And then explain it. So pause the video, answer these, and then come back. Okay, let's see how you did. Number 7. Let's see, they have the same central angle. The radii are congruent. So the circles are congruent. So these are congruent arcs. Over here, they have the same central angle. The radii are not congruent, so we do not have congruent circles, and therefore the arcs are also not congruent. Alright, so that's a basic introduction to arc measures. Hope this was helpful, and I will see you next time.